Welcome to our talk about the migration. My name is Alicja Kucharczyk. I'm EMEA Global Black Belt OSS Data Tech Specialist at Microsoft, and together with my colleague Sushant Pandey from SQL Ninja team, we conducted a successful migration from Oracle to Postgres for one of our customers, and that is the story that we would like to tell you a bit about. So, starting, that was the migration from Oracle Exadata system, and the target database was Azure database for Postgres, which is PaaS service, which you can find on Azure. The target version of Postgres was 11. And as you can see, like there's been a similar, not exactly the same configuration of the source and target database. So both instances had 4 vCores, and on Postgres we had 16 gigabytes of RAM, on Oracle 32 of them. The scope of the POC was only 2 packages out of really many of them. That was like huge system loaded with the logic. So the customer chose 2 packages, which were the most complicated, to showcase if a Postgres will handle it well. Besides of 2 packages, we also migrated some single objects and some schemas, so tables from another schemas that were dependent. For instance, we migrated also the whole package for logging, because our packages was using that. Success criteria, that was basically the performance. So the main aim of this POC was to check if the Postgres can at least be so performant as Oracle Exadata was. And the tests we ran were based on a custom script written by the customer, which was going through those packages and running the procedures inside of packages with different values. The main tool that we used for this migration, it's probably the most famous and the most widely used tool for Oracle to Postgres migration, Ora2PG, which kind of created a framework for the migration. So maybe not all the procedures, not the whole stuff was migrated automatically, but a lot of that, and the rest required some manual effort and some optimization. So first, we wanted to show you the results. So Sushant, over to you.
Thank you, Alicia. I hope you can hear me okay. All right, so let's talk about the results. The results were taken in 3 different parts, actually. So the first one and the second one and the third one, the test cases or the test sets which we saw was we had node 1, which was execution 1, and then duration, and node 2 duration, and so on. So for the test 1, which was for one of the function which was using the tree traversal kind of mechanism for the hierarchical queries and the output. As you can see, for the node 1, 2, the Oracle performance was quite good compared to the PostgreSQL. And in the node 7 also. What we saw overall for the test 1 was that Oracle performance was quite good, and the Postgres performance was about 12.5% of the Oracle. So we were quite behind in this piece. However, this is not the end of the story. We had some good news when we actually conducted other tests. So in the test 2, which we call it as cursor-free execution. So this was for one of the function where we did not use any type of cursors, but whereas Oracle, the original Oracle function, was actually using multiple cursors there. So we converted that code and tried to use the set-based queries. As you can see, for the node 1 to 10, we had got far better performance in the Postgres compared to Oracle. So this, you see, it is about 800. So it's about 873% better compared to Oracle. So this was one function where we received a far better performance. There was another function or the test scenario which we executed. It was again for the cursor-free execution, but here we had one interesting scenario which we came across, which we'll talk about in detail a little later. In this particular execution or test, we performed for 2 nodes, and the node means 2 different executions with different values. Here you also see better performance overall compared to Oracle in Postgres. It is about 117% of Oracle. So we were better in PostgreSQL. Yeah, so these were the test results. Now I am handing over to Alicia to talk about few code migrations that we did. Yeah, over to Alicia.
Yeah, thank you, Sushant. So we don't have time to talk about each particular part of this migration because we've got only 30 minutes, but we've just chosen some most important one, in our opinion. So let me start from sysconnect by path clause that is present in Oracle, but in Postgres we do not have the same clause. We don't have this statement. And the common way of migrating that to Postgres is by using with recursive, which is probably one of the slowest queries that you can have in your Postgres instance. So we tried to avoid those kind of queries where possible, of course, because there is not possible in each case to get rid of this with recursive. Sometimes it's really necessary. So sysconnect by path, as you see, it's used in hierarchical queries. So it's just returning the whole path of a column value from root to node. And you can choose the custom separator of those values. So it's kind of when you've got ID and parent ID scenario, and you are traversing to the tree. So that's a code snippet from Oracle. It's only really small part of the whole procedure, of course anonymized. And as you see here, there is a sysconnect by path used with the comma, and then there is window function used, and the whole execution took 45 milliseconds. And as you see here, because there is a dbms output statement, so you see that this particular snippet is producing just the ordered list of the numbers. So pretty simple thing. In Ora2PG, beside of export script that I commonly use, and I always use this export script when I do start the migration, you can also use the conversion of particular objects, so procedure, type, or just a query to Postgres. And as you see, I just put it like this Oracle snippet to the file and told Ora2PG that this is a procedure, and that is the output that Ora2PG produced. Those parts that are highlighted in red that you may or might not see, with recursion twice begin into strict, like in the second part of the union. Also the table statement, those are like pretty much the bugs, right? That will not work on Postgres. So even if Ora2PG in this case like helps you like to get some kind of like the framework, the template of the migration, you would need like to put some manual work to make it work, like that, get rid of this double begin statement, get rid of this table after from, because it doesn't exist, the syntax in Postgres, and also as you see like double semicolon. And even if you do put this additional work to this particular procedure, that will not be super performant on the Postgres side anyways, because like with recursive, it's really a kind of very slow query. So the thing that we did, it was like just totally rewrite that, like to keep just to keep the logic. So like if you've got the set of the input parameters, it should produce the same output parameter as is Oracle, but as you see that the statements were totally changed, and that is something that we consider as really good practice. So instead of like writing your own functions, trying to reinvent the wheel, so first shot should be like to try find the native Postgres functions that you can use, and like use it instead of custom written ones. So we have used like unnest, which is like native Postgres function, and just order it by here, and then used a string AGG function, which is a simple string aggregation, and that was actually it. As you see also, like we haven't created like the additional data type, we just used array of numerics for that. Could be integer, by the way. And as you see, the execution time was just 3 milliseconds. So instead of with recursive and complicated code, yeah, we just used unnest function and string AGG, and we had like 1 order of magnitude faster execution on the Postgres side. Okay, the second example I would like to show you, it was like loaded with bulk collect, cursor, and for loops, so nested loops. Bulk collect, for those of you that are not Oracle DBAs, this is the clause that does some operation in bulks. So instead of like going through one row and then like looping through single rows, it's just doing some operation like on set of the rows at one time. And we don't have bulk collect clause in Postgres also. That's the snippet from the Oracle. As you see, the first here is the cursor, which was used. Then we opening the cursor at the beginning, fetching it to the bulk collect. Then we've got the first loop, and then goes like the second loop, which is reverse loop, and then we aggregate the string. So in this simple and really short snippet, you see cursor, 2 for loops, and bulk collect. It's really not an easy one for migration to Postgres. Again, if you do migrate the snippet with Aura to PG, what you will see that Aura to PG does not handle bulk collect at all. So it doesn't even like try to convert it. It's just leaving bulk collect as it is, and obviously that will not work on Postgres. And actually, the code is pretty much unchanged. So what we did again, it was totally rewriting the whole procedure. First thing that we also did in other procedures was we took the cursor outside of the function, because it was quite commonly used cursor. It was used in many other procedures. So instead of putting the same cursor over and over again, we created a SQL function. Yeah, that's important. It's not PLPG SQL function, but it's SQL function, and we just put it here. Then, as you see, that's completely different kind of statements. So we don't have bulk collect, and one of the way to migrate those is to create temporary table. Because in bulk collect, if you do have that in Oracle, you can do, for instance, count of bulk collect. You can fetch like particular rows. You can do a lot of operation. In Postgres, you can just traverse through the results, but you don't have that many options. So a temporary table does give you those kind of options. If you've got even like bigger data set, you can put indexes on this table to make it more performant, and you can do a lot of stuff with that. So as you see, the first what we did was we ran this function, which is the old cursor. Then we saved those results as temporary table, and also deleted all the rows where row number was 1. Why? Because yeah, that doesn't. This is not obvious, but if you go back to the Oracle snippet, then you will see that the last loop, it's reverse loop. So it's kind of like starting. It's like starting with 2. There is no 1. So the Postgres way, the temporary table way of migrating that would be, for instance, just deleting those rows, and that you see analyzed because Postgres doesn't run auto vacuum on temporary tables. And then we've got just one loop instead of nested loops. And using again a string aggregate function to put like the results together. So if you would take a look at both sides, it looks like totally different procedure, right? And basically it's producing exactly the same result. Sometimes it's not possible to migrate in the same way as it is. Sometimes you need just to understand first what is happening inside of your procedure, and try to choose the statement, the way of doing stuff like in totally different way. Because we need to remember it's that completely different engine anyway. So as you see here, like we also achieved with this rewrite much better performance as in Oracle. So 14 milliseconds versus 41 milliseconds. Okay, the next example, Sushant, is take over.
Yeah, Alicia, thank you. Okay. So this snippet that you see here is the conversion of Oracle function into Postgres. The uniqueness of this function was that it was using a lot of table functions which are native to Oracle. They were using the dynamic queries, and they were using the ref cursor as the output or output type of the function or the procedure, we can say. Now, what we did is actually we converted that into the return type as set of records instead of ref cursor. We actually compared both of them in the Postgres SQL and found that the set of record performed far better compared to the ref cursor. For those who can actually identify these yellow colors, I am trying to highlight that, inside the dynamic query, we were using unnest function, which was to open the arrays, which were passed as the dynamic parameters to this particular query. And the result set of this dynamic query was actually returned as the set of records to the calling function. There is another yellow section at the bottom side, which is then talking about how do we return the set of records using the dynamic queries from a Postgres function. The execution time which we saw here was 31 milliseconds, and this is in comparison to Oracle of about 28 seconds. So we saw that set of records was the better choice compared to ref cursor in our case. Now, moving ahead, this is the piece which I spoke about in the third test result, which we saw. This is the specific scenario where we saw that data type mapping of the fields which are joining to each other to get the results can be of bit problematic if they are not same. How did we realize is we had a query which is given on the left hand top corner side where we are joining. So I try to highlight that in yellow, and if people are not able to identify that yellow, I'm talking about the first join, which is on table D and table E. This was the join which was happening. So the table E column was of numeric type and the table D column was of big int type. Now on the right hand side, you can see there are two comparisons. This is actually done after we identify the problematic situation. So the middle section of this screen tells you about the execution plan, and in this execution plan, the red highlighted section is something I'm talking about, where the column of table D is getting typecasted to numeric to match its type with the type of column E, which was numeric earlier. Now, because of this change, we were, or this typecast, actually, we were seeing the performance like the function was taking somewhere close to 9 seconds. When we actually converted this numeric type column to big int and then executed the query, we got super fast performance, as you could see in the bottom image of the slide. I tried to highlight that in yellow, but if you are not able to see that, there is a section which says it is the index scan happening now, because there was a scan on table D, which was not getting used when we were having different data types. When we had the same data types, this index was used and we got the desired performance, and it was 31 milliseconds. And this was better than compared to Oracle in the actual results. So this was one of our experience. Based on our experience of this whole work, what we saw is there are actually some generic rules that we could probably follow. We are not saying that every time you will get the performance better than Oracle, but in our scenario, we actually most of the times beat the Oracle. So some generic rules that you can probably follow is for the nested loops, try to reduce the looping in when you are actually converting the code, and put some kind of improvements, as Alicia also mentioned in her examples of Oracle as well as Postgres conversion. Then if we have some kind of dynamic queries, we can actually try to improve the dynamic queries and make them more performant. Actually, we were able to do that after changing some logics. We were able to get the performance by reducing some of the for loops and so on. Then there are ref cursors. So we compare the ref cursor execution with the set of records as the output type, and we actually found that set of record was giving us the better results. So this was one piece. Then this was about a whole story that we actually worked on for one of our customers. Now, if you want to go ahead and find out more about the Azure database for PostgreSQL, there are a few links which you can go and have a look at the information available. There are some blogs from Microsoft side on PostgreSQL, and there are a few documents which are available, and migration tutorials are available as well. Then if you have some more information that you need, there is one version which is called Citus, which is open source. You can go ahead and read about it in aka.ms/Citus. If you have further questions about the Azure database for PostgreSQL, you can reach out to us on the given email address. So that is it from our side, and you can see Alicia has again converted back to the elephant, Postgres elephant. So that's all from our side. Thank you, folks. Thank you, everyone, for listening us. And the forum is now open for the question and answers. So please go ahead and ask your questions. We are here to answer them if possible. Otherwise, we can be contacted over the email addresses, and later on we can share our thoughts. Thank you so much.
Okay, and now Alicia and Sushant have already joined me. Thank you for your detailed talks about the migration. And I guess now we are ready for Q&A session, and I remind you that you can ask your questions in the chat. So let's see what the questions are. Okay, so while we are waiting for the questions, I guess I'll take from here and I ask my question. So did anybody in other teams benefited from your learnings? Maybe some other team implemented your migration, like textbooks?
Yeah, maybe I will take this one. So, because we doing a lot of migration, not even my team, but also Sushant's team, and there is other teams that doing a lot of Oracle to Postgres migrations. So we absolutely do share those learnings. It's not easy to do simple automation, because as you've seen in the presentation, those kind of statements are not easy not easy to be migrated really, and because it was also migrated for performance, that makes it super difficult to write a script or automate it somehow. So yeah, we do share internally and externally, like on this conference, this knowledge, so more people can benefit from that. So yeah, so we are trying.
Okay, so maybe you can have something to tell about Oracle PG, advantages, disadvantages. Where does it really help you?
Yeah, so that's a great tool that we do use for migrations. Of course, it does not migrate everything, unfortunately. The problem that we have, it's even with partitioning. It's for instance, it doesn't actually migrate at all reference partitioning. So that's the part that we always need to do manually with some workarounds. The second thing, it's it does migrate simple procedures and functions, but if you've got a bit more complex ones, then yeah, the manual work is still needed. But actually, I think that the big advantage of it is at least it generates you the structure for the migration, so it helps anyways. So if you've got the structure normally generated by Oracle PG, you can have it you can have it under the Git or another tool, and you can start working on that. But yeah, with those complex migrations, as you've seen, as we shown you in this presentation, there is probably no tool that will do it automatically.
Okay, so the next question is, which Exadata, full or is it part of it?
It was part of it because like part of this Exadata was migrated to another custom solution, like in Azure. So we just migrated like a part of the system that was responsible for keeping like kind of metadata.
Okay, thank you. So the next question is already here. How many active users, active sessions in the same time for which for production database do you have? I think that's how many active users in the same time do you have in production database, I guess?
I don't remember, to be honest. Sushant, maybe you recall.
No, unfortunately, that number is not available with us right now.
Yeah.
Okay, so maybe you can share some other like major or main learnings after the migration.
Yeah, I like to add one thing on Aura to PD side. Most of the people which we are interacting with, they also come up with one question which says, how do we do the online migration? Because Aura to PD is pretty good for doing the offline migrations. So if there is some kind of tooling, which is again open source tool, or maybe like in Aura to PG, if that kind of feature is available, then will definitely help more people.
Okay. So I guess that so there is like no questions in the chat, so you answered them all. So I just want you to thank you again for taking part in PGConf and for your talk.